Yes.
So, okay, when the dragonflies, if they were that big and everything, were humans also relatively in scale the same, like
We're
much bigger, or how?
Well, what they measured it in cubits. How big is a cubit?
I forgot.
From here to here.
Okay.
So there was no independent measure. So we don't exactly know how big the people were. It could have been much taller. You know, they said there were giants living. Goliath was big.
Oh,
You know, who was that guy? Chu, who's the basketball player, is what, 8 feet tall?
Yeah.
I mean, people get big. Okay, we've got to move on. Carbon 14 summary. Carbon assumes a constant ratio between the equilibrium is acknowledged to be false. We know that there are large factors that could have, in the past, like the Genesis flood catastrophe, could have affected the ratio. And all this stuff contains C14 measurable amounts, so therefore the Earth is probably young. Let's go look at radioactive decay. You all know about this, right? Uranium turns into lead, spits out an alpha particle. What's an alpha particle? That's a helius. The nucleus of a helium atom. That's 2 protons and 2 neutrons. Spits out. It's called an alpha particle. And since it changes the number of protons, it changes the element to something else. And the 2 big ones are potassium and uranium. This is called KAR. And so what happens is that these alpha particles go flying out. And this just means there's more of these alpha particles. It goes through this great big long line of elements until eventually it ends up with lead, 206. Okay? Makes sense? We see that all the time. You have atom bombs and nuclear power plants. You know about this. Okay, here's an hourglass example. Here's a door. And there's an hourglass. How long has that hourglass been running? Please tell me.
We can't.
What can you do? You can count the amount of sand here, and you can count the amount of sand there, but you don't know when it was flipped.
We don't know how.
Or how many times it was flipped. Right. Or it might have been flipped the other way, and just before you opened the door, they flipped it again. Whoever, this sneaky person behind there. So just like carbon 14, the starting point is really important. So the 4 assumptions of this are that we have a known starting amount. So do we know if we can have a known starting amount? Not really. All the daughter elements are due to radioactive decay, not leaching. Say it's in the some other process is causing these daughter elements to flow into that, or contamination is another problem. We don't know. We assume it's not contaminated. And the decay rate, here we go again, has always been consistent with today. And we recently have discovered, in the last several years, that neutrino activity on the sun changes the decay rate of atomic particles. They discovered that at the University of Chicago just this past year. And we also know that if for some reason the electrons are stripped from a nucleus, the radioactive decay goes up a billionfold, the rate. So almost always, overnight. In a second or so. So it's like C14. These assumptions really aren't provable, but it's good swag. Scientific wild-ass guess. Oop, I didn't say that. Here's some real examples of dating. Okay, Sunset Crater, northern Arizona. Who's been there? I've been there. Andrea and I have been there. By potassium argon, right? That was the K, potassium K, argon. 200,000 years dating. Well, guess what? Inside the lava, they find human artifacts, and we actually know that it was that leak that occurred in 1065 AD. Lava flows at Mont. What?
That's in petrified forest.
Arizona. Yeah,
So
nearby. It's right north of Phoenix, right?
Mm-hmm.
Lava flows at Mount Ngauruhoe in New Zealand. Potassium argon dates it at 275,000 years. In reality, we know it occurred in 1949, 1954, 1975. And what they say is when this is the assumption, is that when the solidified rock, when the liquid rock solidifies, there is no argon gas, an inert gas, in that rock, in the liquid rock. Well, probably maybe not true, but that's what it's based upon. And so that starts the clock. And Hualalai, basalt in Hawaii, 12 dates, we got 12 dates here, range between 140 million and almost 3 billion years. The average is about 1.4 billion years. And by potassium argon, we got 1.4 to 22 million years. In reality, we happen to know, because we watched it, remember we said unobservable past. This was the observable past, 1801. In Mount Etna, in Sicily, potassium argon, 140,000 years to 350,000 years, reality, 1972. So when they say it's been reliably dated, it isn't necessarily so. Because what they do is they take all kinds of dates, like 15 or 20 dates, using different methods, and they throw out everything, and you'll get widely different dates depending on which time of day or how you hold your mouth, results, and which method you use, and you throw out the ones that you don't want, and you publish the ones that match your hypothesis. And if you'd like me to provide you the reference in various geology and chemistry textbooks, just send me an email. I will show it to you. Okay, I didn't put it on here.
They do that in the face of knowing when it actually occurred.
Well, what they say is if the result, one of the results matches their hypothesis in a science publication, they will publish that in the text. If it's close, or it's not exactly what they thought it would be, they publish it in a footnote. And if it's not anything at all, they reference it in the index. Okay, but they don't put the number in there. And this is a common practice among publishing scientists. Okay, this is a common practice. Does that sound like the truth? These people who would never lie to us or never falsify anything. And here's, well, gee whiz, guys, you know, what can I say? I don't believe this. More examples. Here's some really good ones. Mount St. Helens, we've heard about that, right? Like potassium argon dating is 1886. We know that there was a flow from into the new dome, a lava dome, in 1986, but the measurement is 350,000 years. Okay? Apollo 11 brought back moon rocks. Remember Apollo? And they dated the rocks using 4 different methods, and the range between the oldest and the youngest was between was like 1 to 6 billion years. Okay, something like that. And then Apollo 16 brought back more rocks, and then they dated those rocks, but it was 18 billion years. Oh, wait a minute, hold it. That's way out of kilter. So what did the scientists do? To fix it, they took the same rocks and they dunked them in acid. And the idea was to remove a lot of the lead that was in there, because this is uranium lead series, right? And then they obtained, after they did that, they tested it again, and they obtained a date of 4.5 billion years, and they declared it success and published it. Interesting, isn't it?
Well, now, I don't understand a lot of this stuff, which is fine.
Okay.
Because I accepted that from the beginning. You don't even need to rework it. But I do have a question about, this all started with evolutionists, but now we're talking about geologists.
That's right.
So
because
what have we done here? Because you said sciences were independent.
No, they aren't.
But in this case, they're not?
No, they're not. But the evolutionists are looking, well, geologists are evolutionists too.
Okay. I know as far as the fossils go, they would be, but now we're just talking about...
No, those are paleontologists.
Oh, okay.
Okay. They're all evolutionists because they say there was this great big long period of time for the creation.
Okay.
And they're all looking for these numbers.
Okay.
And so when they don't find a right number, They throw it out and start all over again and
Yeah.
do some
Just
laboratory
who
tricks.
God? Who is God?
And by the way, you can read
Has to
this.
do
You
that.
can read this. There's a reference in Science magazine. The most prestigious magazine in the Science Academy, published in the United States. Okay, lots of manipulation of data. Okay, I don't believe these ages. Here's one. Here's something pretty easy to see. This is a formation in the Grand Canyon, and as you can see, this part is called Paleozoic, meaning old stones, and Precambrian. So this is the Cambrian level. And using different dating methods, you can see the range of dates. And what you'll notice is that the ones on the top are older than the ones on the bottom. Using the same dating methods, the ones on the top are dated older, tested older than the ones on the bottom. Interesting? Find that interesting?
Well, I don't know how those guys sleep at night.
Well, they don't
I mean,
have.
that should be very
They don't have a
disconcerting.
creator to be accountable to. And so radioisotope dating, the dates are never right. When we know the age of the rocks, how can we actually be sure they're correct when we don't know the exact age of the rocks? So that's my point on radiometric dating, which is it's pretty loosey-goosey. Does that answer your question? Okay. Evidence for a young Earth. This is a very short thing. Geologic evidence is for a young Earth. Polystrate fossils. Who remembers those? Right. Big tree trunks buried in multiple layers of sediment that are supposed to, each layer is supposed to be 100,000 years old. So how could a tree be 10 million years old? It exists for 10 million years while the sediment is building up around it. We have pictures of that. We had that in chapter number 3. Lack of living communities in rock strata. What we find in rock strata of fossils are dead fossils. Dead fossils. Jumbles of bones. When we find a fossil, it's either like clams smashed together, and they aren't actually dead, but they were buried quickly, or if they're vertebrates, they're almost, if they're attacked, they're almost always in the arched position like this with gaping mouths, which is called asphyxiation. Lack of soil layers between strata. You don't find it. Maybe you might find a little teeny one, a flow layer, but not much. And the limited extent of unconformities, that is to say, long horizontal layers like pancakes, laid upon one upon the other. Soft sediment deformation of strata everywhere. If you dig into a mountain, what you see is the strata looks like this, according to the topology of the terrain. So how did that limestone bend? Sandstone bend. You know limestone and sandstone doesn't bend. The reason was it was once wet and there was a great crushing activity and it buckled and that formed mountains. Sharp edge contact between adjacent beds. That's why we know there's strata. There's no erosion between the beds. Retention of surface features on lower beds. What you'll see are ripple marks on lower beds and then when the current changed, the lower bed started to solidify a little bit, and then the flow started on the one above that, on top of that. So like the tide went out and the tide went in the flood, and then you'll actually see the ripple marks are preserved in the lower layers. Interesting. And also think, so if there was a slug moving across the surface of the lower layer underground, when the new layer comes plopping down on top of it, you'll actually see the tracks of the slugs, or worms, or whatever they are. Or human footprints or dinosaur footprints. More accurately, what I believe this shows is that the geologic evidence of a quickly formed geologic strata, a recent massive global hydraulic event. Just looking at it, forget the story. You're a creature, an intelligent creature from Mars, you land in a spaceship, you can't understand anything anybody's telling you, and you just look, and you say, oh, that's what makes sense to me. You haven't heard propaganda. A young